that you are having a wonderful day. Um, this video is for grade 7 students, and it's a continuation of the discussion that we have had on solid shapes. I'm sure you can remember that we have already treated the properties of solid three-dimensional shapes, properties of the cone, of the cylinder, of the sphere, of the cube, of the cuboid, of the pyramid, and things like that. And this presentation is sequel to the last interactive class that we had. You remember we had some network challenges, and I decided to do this presentation as a way of following up on what we discussed the last time. Alright, so solid shapes, let's get right into it. The objectives of this video is that at the end of this lesson you should be able to recall and use the formula for solid shapes appropriately. Okay, so you are going to have to learn these formulas by heart and know when it is appropriate to use each one of them. And secondly, it's to determine the volume of cubes and cuboids using the volume formulas. And the reason why I deliberately want to emphasize this objective is that it is very, very important for you at this stage, okay, of the three-dimensional shapes. The ones that will focus majorly on, or that you should focus majorly on, are the cube and the cuboids, okay, because they are quite important for you at this moment. Then before we get into the work proper, it's also okay for us to do a little bit of definition of terms, a few words that you're going to see as we proceed with our class. The first one is the TSA, that's the total surface area, and this is the sum of all of the surface areas of each side. So if you have a three-dimensional shape, obviously there will be different sides and each side will have an area. Okay, now finding the area of all the sides is what's called the total surface area. So you find the area of each side and add to the area of all the other sides. You understand? That's what the total surface area is. It is measured in centimeters squared or in units squared. Okay, centimeters squared, meters squared, depending on whatever units you're given. But then that's what total surface area is. Also, we have what is called the CSA, that's the curved surface area. And for the curved surface area, it is the area of all the curved regions of your solid. So if you have a curved surface, for example, like your cylinder, you know, your cylinder, it has a top and a bottom, and then both are connected by these curved surface. Now the curved surface area is the area of that curved region, okay, of your solid, and that's different from the lateral surface area. You also have what we call the LSA, which is the lateral surface area, and that is the area of all regions apart from the base. Okay, so in this case it might not particularly be curved, but every region of your shape apart from the base, the base is that that lower part where it's resting on, and of course the opposite side to that. Okay, that's the base for mostly for cylinders anyway. All right, but the lateral surface area is the area of all regions apart from the base of your shape. And the last one that I'll deal with under this definition of terms is the volume. The volume is the amount of space that is contained within an object or solid shape. So when you have a solid shape, you remember that a solid shape has a hollow. It has space inside. And the amount of space that is within that shape is called the volume. So if you have to find the volume, you're trying to find the amount of space inside. Of course, that could be filled with liquids or gases, you understand, but basically it's the amount of space that you have within a solid shape. Okay, and the next thing that we will deal with will be the formulas, and we will pick them one after the other, starting with the sphere. Okay, the sphere. Now the sphere has two major formulas that you need to keep in mind. Remember, you must be able to recall and appropriately use these formulas. The first one is the volume, and the volume of a sphere is calculated by V equals to 4 over 3 times pi times r cube. 4 over 3 pi r cube. That is the formula for your volume of a sphere. And then the formula for the surface area of a sphere is 4 pi r squared. I'm sure you can remember we already dealt with this in our last interactive class. Okay, the surface area of a sphere is 4 pi r squared. Alright, so let's look at an example under this. It says, this example says, find the volume and the surface area of the sphere that has a diameter of 10 centimeters. So we have a sphere that has a diameter of 10 centimeters. So it means that the diameter, if the diameter is 10 centimeters, obviously the radius is 5 centimeters because the radius is half of the diameter. So our radius is 5 centimeters, and the formula for volume, starting with that, is 4 over 3 times pi times r raised to power 3. So we insert values. 4 over 3 times pi, we're using 22 over 7 times the radius is 5, so we have 5 raised to power 3. And when we do our calculations, our multiplications and divisions here, we get an approximate value of 524 centimeter cube. Okay, that is the volume of that sphere. Okay, it's an approximated value anyway, but then you get the general idea. Then the surface area is calculated by 4 pi r squared. So we insert values once again. 4 times pi, which is 22 over 7, times r squared. R is 5, so you have 5 squared. And when we perform our multiplications and division, we have approximately 314 centimeters squared. You would notice that the surface area is in centimeters squared, whereas the volume is in centimeters cube. That's really very important for you to note. Volume is always in cubic units. Volume is always in cubic units, whereas area, whether surface area or curved surface area or total surface area or lateral surface area, they are always in units squared. Alright, the second one we'll go to is the cylinder, and this is what the cylinder looks like. I'm sure that many of us are familiar with that. If you can read the labeling, you can see the top and the bottom, which are both referred to as the base, and then you have the curved surface, that curved part of the cylinder. The formulas that you have to keep in mind for cylinder, you have the volume, which is calculated by pi r squared h. Pi times r squared times h. The second one is the total surface area, which is the area of all the surfaces. So you had all the areas of all the surfaces, and what you get is 2 pi r into bracket r plus h. 2 times pi times r times, then you open a bracket and add r plus h. That's very important. And then the last one is the curved surface area, the CSA, and the formula for that is 2 pi r h. 2 pi r h. You can see the formula for the circumference of a circle, 2 pi r, is being multiplied by the height. Okay, so the curved surface area is 2 pi r h. Perhaps we can look at an example as well under this under the cylinder. And the example here says find the total surface area and volume of a cylindrical shaped water container whose radius is 5 centimeters and height is 10 centimeters. So we do have a cylinder, and the radius is 5 centimeters and the height is 10 centimeters. We are told to find the TSA. The total surface area, formula for that is 2 pi r times r plus h. So we insert values into that. 2 pi times r is 5 times r plus h will be 5 plus 10, and then in the bracket you have 15 multiplied by 5, and then that's going to give us 75. So you have 2 pi times 75. Final answer is 471 centimeters squared. That's approximate value of the total surface area, or the area of the surfaces of the cylinder. The second question asks for the volume, and formula for the volume is pi r squared h. So we insert values once again. Pi times r is 5, you have 5 squared, times h is 10. You insert that value, and if you perform your multiplication, the final answer is 785 centimeters cube. 785 centimeters cube. All right. Next we will look at the cone. We'll look at the cone, and the cone, that's the shape you see on your screen. It has a curved surface as well, and of course a plane surface as well. Now the formulas that you need to keep in mind on the cone, there will be 3 of them, and the first one is the formula for the volume of a cone. The volume of a cone is calculated by 4 over 3 times pi times r squared times h. 4 over 3 times pi times r squared times h will give you the value for the formula for the volume of a cone. And then the total surface area is pi r into bracket r plus l. That is, you multiply pi by r, and then you multiply that by the sum of r and l. And L, that's a new one, because that's not the height. The height is represented by h. You can see that in the volume. So what is L? L is called the slant height. Now the height h, if you drew a line from the vertex of this cone down to the circular plane shape, a straight line from the vertex down, that is the perpendicular height, and that is h. But you see, the line that you draw from the vertex through the surface of the cone, to the base, that is a slant height, which is L. Okay, so if you know what a right angle triangle looks like, then the slant height would be what you would call the hypotenuse side of the right angle triangle. The vertical height h will be the opposite side of that right angle triangle. Anyway, so the formula for the slant height is L equal to square root of the sum of the squares of r and h. So you have root of, then you open a bracket, r squared plus h squared. You need to remember these 3 formulas as well, because they might prove useful in answering questions at various times. Let's look at an example here as well. What is the volume and total surface area of the cone with the radius 3 centimeters and height 5 centimeters? So we have the radius, which is 3 centimeters, and the height, which is 5 centimeters. Now we have to find the volume. Volume is 4 over 3 times pi times r squared times h. So we insert values. 4 over 3 times pi times r is 3, so we have 3 squared times h is 5. We'll put that, and if we perform our multiplications and division, our answer would be 189 centimeter cube. 189 centimeter cube. And then next we want to find the total surface area. Like we were told, the TSA can be calculated by pi times r plus l. That's inside the bracket. So we need the value of L, which is the slant height. Now if you have not forgotten, I told you that the height h is not the same as the height L. The height h is the vertical height, and the height L is the slant height. Okay, so we have to use this formula that says L equals to square root of r squared plus h squared. R squared is 3, r is 3 rather, and then h is 5, so we insert that, and the final answer for our slant height is 6. Now that we have that, we can use the formula for the total surface area. We just insert values. Pi times r is 3 times r plus L, that will be 3 plus 6, and then we perform our multiplications and addition and multiplication, and our final answer will be total surface area is 85 centimeters squared. Is 85 centimeters squared. So we've been able to determine the surface area, that is the area of all surfaces on this cone, and we have also been able to find the volume, and you'll notice that the volume of the cone is much larger than the total surface area, because volume actually brings in more parameters than the area would do. Let's look at the cube, which is the fourth one. Like I told you, this cube and the cuboid are very important for you. The formulas are important, that you should keep them in mind. Alright, so the cube, the volume of a cube is the edge length raised to power 3. You know what the edge length is? The length of the edge, okay, the length of one of the edges on the cube, and then you just raise that to power 3. And the reason is because the cube has the same edge length all round, so the volume would just be length times length times length, and you get your answer. The surface area is 6 times length squared. For the cube, the surface area is 6 times length squared. That is the square of the length. And then last but not the least, and this you might find this also very useful, is the perimeter of a cube. And perimeter is the sum of all the edge lengths, and there are 12 of them. Okay, so it means that the perimeter of a cube is equal to 12 times edge length. 12 times edge length. So let's see an example under the cube as well. And this example says if the value of the side of the cube is 10 centimeters, it says then find its surface area and volume. So we have the edge length to be 10 centimeters, and we have to find the surface area and the volume. The surface area we know is 6 times edge length squared. So we square the edge length, which will be 10 by 10. That will give us 100 times 6, and then we have 600 centimeters squared for the surface area of the cone. And also we were asked to find the volume of the cone, and we know that the volume is edge length raised to power 3. So we just raise 10 to the third power, and our answer would be 1,000 centimeter cube. 1,000 centimeter cube. Let's look at the cuboid as well. The cuboid, rather than have square faces like you have in the cube, it has rectangular faces. Well, that's basically the difference between them. Anyways, the formulas to keep in mind under cuboid, I have 4 of them. The first is the total surface area, which is 2 into bracket length times breadth plus breadth times height plus length times height. So you multiply the sides in pairs, and you add that together and multiply the answer by 2. The lateral surface area, which is LSA, can be determined by using the formula 2h into bracket L plus B. 2h into bracket L plus B. That would be the area of the side that can be seen on a cuboid. The next one is the volume, and the volume is length times breadth times height. Basically the same thing as you have in the cube, only difference is that the length and breadth and height in a cuboid might be different. Okay, but in a cube, length, breadth and height are basically the same length. And last but not the least, the perimeter of a cuboid, you have 4 into bracket L plus B plus H. You add the length and the breadth and the height, and then you multiply the answer by 4. Let's look at an example on that cuboid. It says find the total surface area and lateral surface area of a cuboid with dimensions 2 centimeters by 3 centimeters by 7 centimeters. Those are the length and breadth and height. Okay, so we can state that the length is 2 centimeters, the breadth or width is 3 centimeters, and the height is 7 centimeters. We want to find the total surface area. 2 into bracket length times breadth plus breadth times height plus length times height, and we perform all of that operations. Length times breadth, that will be 2 times 3, breadth times height 3 times 7, length times height 2 times 7, and then we multiply the sum of that by 2 to give us the value of the total surface area. And having done that, the final answer is 82 centimeters squared. It's 2 centimeters squared. And then next we want to find the LSA, the lateral surface area, which is 2h into bracket L plus B. 2h into bracket L plus B. Alright, so we insert values into that. 2h is 7, so we multiply into bracket 2 plus 3. The bracket gives us 5, multiplied by 7, that's 35, multiplied by 2, that would be 70 centimeters squared. So the lateral surface area of that cuboid would be 70 centimeters squared. Alright, so what we want to do now, basically that's the formulas I want to give us, and it's important for us to try to memorize those formulas so that we can use them appropriately. But before I leave, I want to do a little bit more examples that will make use of the formulas that you have been given. How many centimeter cube are in a cube of h 2 centimeters? And when you see how many centimeter cube, then the question is actually asking us for the volume of the cube. Volume is in units cube, so it's asking us for the volume of a cube that has a length of 2 centimeters. Obviously, formula for volume is h length raised to power 3, so you have 2 raised to power 3, and that will give you 8 centimeter cube for your volume. Okay, for your volume. Number 2 question says that a box has a square base of side 9 centimeters. It has a square base of side 9 centimeters. Calculate the volume of the box if it is 10 centimeters deep. Okay, we want to calculate the volume of a cuboid that has a length and breadth of 9 centimeters but a height of 10 centimeters. Basically, that's what we have been told. So the volume of the box would be length times breadth times height. That's the formula for the volume. And then length and breadth, that'll be 9 times 9, and then the height, that'll be 10. So final answer is 810 centimeters cube, and that's really important. Question 3 says a rectangular room 8 meters long and 5 meters wide contains 120 meter raised to power 3 of air. Calculate the height of the room. Since the volume is length times breadth times height, obviously the volume is 120 in this case, and that equal to length is 8, breadth is 5 times height. Height would be, we're dividing both sides by 8 times 5 rather, and so we perform the division, and our height would be 3 meters. Okay, our height would be 3 meters. So in this particular example, you can see that we were given the volume, and then we had to use that to calculate the height. So whatever you're given, it's important to use them appropriately. Question 4 It says a room is 3 meters high and has a volume of 60 meter cube. Calculate the area of the floor of the room. So we want to calculate the area of the floor of the room. Recall that your volume is length times breadth times height, but your area is also length times breadth. Remember that? Your area is length times breadth. So if you bring that out of the volume, it means that your volume will be equal to area times h, because area is length times breadth. So if you multiply that by the height, then you get the value for the volume. So our area in this case will be 20 meters squared. I'm sure you know what we did in that case. If the volume is equal to area times height, and then we know the height to be 3, then 60, which is the volume, is equal to 3 times our area. And then we divide both sides by 3 and we get 20 meters squared for that. Okay, question number 5 says a flat rectangular roof contains 7.5 meters by 4 meters of space. So the length is 7.5 meters, or measures rather 7.5 meters, and then the breadth is 4 meters. And then 12 millimeter of rain falls on the roof. So rain fell on the roof, and since it's a flat rectangular roof, so it perhaps held the water in place. Find the volume of water on the roof. And then it says in centimeter cube, and then in meter cube. Then question B says find the mass of water that falls on the roof if 1 centimeter of water has a mass of 1 gram, and the answer is to be expressed in kilogram. Alright, so basically what we've been told, we have to make use of it. The length is 7.5 meters, but the question tells us to find the volume in centimeters, so I'll just convert everything to centimeters. So 7.5 meters will be 750 centimeters, 4 meters will be 400 centimeters, and 12 millimeters will be 1.2 centimeters. So what we do in that case is to multiply all three together. 750, which is the volume, length times breadth times height, 750 times 400 times 1.2, and our answer will be 360,000 centimeter cube of water. 360,000 centimeter cube of water. The second question there says we should also find the answer in meter cube. Now we are aware that 100 centimeters will give us 1 meter. So if we find the cube of both sides, then you have 1 million centimeter cube to be equal to 1 meter cube. 1 million centimeter cube to be equal to 1 meter cube. And then we want to find the corresponding value for 360 centimeter cube. So we divide by 1 million, and that will give us 0.36 meter cube after conversion. The second question says we should find the mass of the water that falls on the roof if 1 centimeter of water has a mass of 1 gram. So if 1 centimeter has a mass of 1 gram, obviously 360,000 centimeters will have 360,000 grams. So we convert that. Remember that 1,000 gram is equal to 1 kilogram. So we convert 360,000 grams to kilogram by dividing by 1,000, and we have 360 kilogram of water. All right, so you see, sometimes the question might look a bit difficult or complex, but if you follow the formulas that you have been given, then obviously you would be able to solve those questions by yourself. So here are your assignments. You're using your new general mathematics, and you would go through exercise 16A. It's on page 132, and then you answer questions 10, 11, 13, 14, and 15. 10, 11, 13, 14, and 15. and I would expect that you send your answers to the emails on your screen. Do have a wonderful time. Bye bye.